Now we shall discuss how to draw an isometric scale when an isometric projection is drawn. So here in this problem, we have to draw the isometric projection of a cube. So in each and every problem regarding the isometric projection of any solid, the very first step is drawing the simple front view and simple top view of the solid using type A lines. So after drawing the simple front view and simple top view of the solid using type A lines, we have to construct an isometric scale. So in all the problems regarding the drawing of an isometric projection of a solid, isometric scale is a must. So how to construct this isometric scale? So first we have to decide what is a length which we have to measure using an isometric scale, or up to what isometric length we have to take from this particular isometric scale that we are going to draw. So in order to decide that, we have to look for the dimensions of the solid, in particular the maximum dimension of the solid. So here we are having a cube. So in this problem, we are having a cube of 50 mm edge length. So the maximum dimension of the cube is 50 mm, and when you are drawing an isometric scale, the scale must be capable of at least reading an isometric length of 50 mm at least. It can even read more than 50 mm, but it must read a minimum of 50 mm. So that is the criteria that we have to set. So how to draw an isometric scale in this particular problem? That is what we are going to discuss now. So here I am going to construct an isometric scale. For the time being, I am going to construct an isometric scale which can read up to 50 mm, an isometric length of 50 mm. So if you are having a solid which is having a dimension larger than 50 mm, this isometric scale cannot be used for that. So in this problem, the maximum dimension is 50 mm, so we can use this isometric scale in order to take isometric dimensions or isometric length. So we shall look how to construct it. The very first step is drawing a baseline or a reference line. The very first step is we shall draw a reference line. So we'll be drawing the isometric scale somewhere above the corresponding page, and below that isometric scale we will be drawing the isometric position. So for the time being, I shall draw it in this area. So first step is draw a reference line using type B lines. Then from this end of the reference line, first we shall take an angle of 45 using our protractor. Now we shall draw a length of 50 mm. The maximum dimension of this solid is 50 mm. So we shall draw a 50 mm long line. So this is to be done using thick lines. After drawing a 50 mm long line, divide this 50 mm long line into 5 equal parts, that is 10 mm each. We shall put some markings at these 10 mm points. After dividing it into 5 equal parts, we shall mark here it as 0, this point is 1, this point is 2, this is 3, and this is 4. We shall consider this as the origin of the isometric scale. After marking 0, 1, 2, 3, 4, we shall drop a perpendicular from point 4 to this reference line. Next is, you have to draw a 30, so this is a 45 degree line. Now we have to draw a 30 degree line from the same origin. So mark 30 degrees. Now draw another straight line from this origin to this 30 degree point such that it is just touching this perpendicular that is dropped from point 4. This is also a thick line. Now we shall draw perpendiculars from point 3, 2, 1 and 0 to this 30 degree line. We can have a darkness of some nearly type A lines, and we shall mark here it as 0, 1, 2, 3 and 4. So this 45-degree line, this total measurement is 50 mm. We have divided it into 5 equal parts, 10 mm each. So this is actually the true dimension or true length. And if you measure this scale, totally this is 50. From origin to 4, this length will be equal to 50 into 0.82 or 50 into 0.816. So this length will be isometric length and this length will be true length. So if you need to take the corresponding isometric length, that is which corresponds to the actual true length of 50 mm, you can just measure this dimension. It will be approximately equal to 41. Now we shall mark angles and we shall write here it as true length. Here this is isometric length. We have to mark the two angles also. So this total diagram, it is known as isometric scale, which will be helping to take isometric length. So for this diagram, this isometric scale is enough because the maximum dimension that is to be measured is 50 mm. So whenever you are having a problem regarding isometric projection, isometric scale is a must. We have to draw the isometric scale, and usually this isometric scale carries around some 15 to 20% of the total marks. Suppose we are having 20 marks for a problem, usually some 3 marks to 4 marks it is allocated for drawing this isometric scale. Now we shall consider another problem in which again we have to draw an isometric projection of a rectangular prism. So here we are having a rectangular prism of base 36 mm and 20 mm and height is 48 mm. So it is resting on the horizontal plane with the 36 mm long edges parallel to VP. So I have drawn a simple front view and simple top view of this solid, which is a rectangular prism. So as we require an isometric projection of this solid, we have to draw an isometric scale for this solid in order to get isometric length. So after drawing the simple front view and simple top view of this solid, the next step in this particular problem is drawing an isometric scale. And in order to draw an isometric scale, the basic criteria that we have to fix it, what is the minimum length that this isometric scale needs to be used for? What is the minimum length that this isometric scale can read? And in order to fix the minimum length that this isometric scale can read, we have to look for the maximum dimension of the solid. Here the solid is having 36, 20 and 48. So these are the dimensions of this solid. So here the maximum dimension is 48. We shall round this 48 to 50 mm. So if you draw an isometric scale which can read at least 50 mm, that isometric scale will be sufficient for this diagram in order to take isometric length. So we shall draw that isometric scale. In this case, it is same as that of the previous problem, which can measure at least 50 mm. Here the maximum dimension is 48, we are rounding it to 50. So the same procedure that was followed in the previous case can be used for this problem also. In this problem, we have to draw the isometric projection of a cylinder which is resting on the horizontal plane on its base. The dimensions of the cylinder is, it is having a diameter of 50 mm and a height of 80 mm. So we have to draw an isometric scale here because we have to draw isometric projection of this solid. So in order to draw the isometric scale, what we have to look for, or we have to decide what is the minimum isometric length that is to be taken from this scale. So in order to fix this criteria, we must look for the maximum dimension of the solid. So here 80 and 50 is given, the maximum dimension is 80. So the maximum dimension of this solid is 80. So we must draw an isometric scale which must be capable of at least reading 80 mm. So it can read 10 mm, 20 mm, 30 mm. Likewise, it can read at least 80 mm, up to 80 mm. If you are drawing an isometric scale which is capable of reading beyond 80 mm also, it is fine. So in this problem, what I am going to do now is I am going to draw an isometric scale which can read up to 100 mm. So here the maximum dimension is 80 mm. Even though it is 80 mm, we can draw an isometric scale which can read up to or a maximum of 100 mm. But that 100 mm scale, if you notice, you can measure 80 mm also. In this 100 mm isometric scale, you can read 80 mm also. So we don't have any problem regarding constructing an isometric scale which is able to read 100 mm. So first step is draw a reference line. So from this leftmost point, you take an angle of 45 degrees. Draw a 100 mm long line. And now divide it into 10 equal parts of 10 mm each. Now you can mark here 0, 1, 2, 3, 4, 5, 6, 7, 8 up to 9, and this is the origin. Now drop a perpendicular from point 9 to this reference line. Now you draw another 30-degree line from the same origin up to this perpendicular that is dropped from point 9. So draw it as a thick line up to this perpendicular. Now draw perpendiculars from 8, 7, 6, 5, 4, 3, 2 and 1 and 0 also up to this 30-degree line. So this line, it will be representing the true length, and this line, it will be representing the isometric length. So totally this line is having 100 mm. If you multiply 100 with 0.82, you will be getting it as 82 mm. So this line totally it is 82 mm, and this isometric scale, it will be capable of reading a maximum of 100 mm. 100 mm isometric length. So this isometric scale, it can read a maximum isometric length of 100 mm. So in this problem, we are having 50 mm and 80 mm. So if you want 80 mm isometric length, directly you can place your compass here. If you want 80 mm isometric length, we can directly take it from this isometric scale. So here we are starting it from 0. If you measure 0 to 8, this will be 80 mm isometric length. So if you multiply 80 into 0.82, that will be this measurement, that is from 0 to 8. Suppose you require 50 mm isometric length corresponding to a true length of 50 mm. What is the isometric length? In order to know that, we can place your compass like this from 0 to 5. So this 0 to 5 will be 50 into 0.82, which is approximately equal to 41. So that is how we will be drawing isometric scale.